Hope you're able to see my screen, all of you.
Yes.
Okay, let me get started. So, what we do in this particular lesson is we look at web security. So, I have three parts here. First, we look at one of the foundations for web security framework, that is PKI infrastructure, that is public key infrastructure, and what is the role of certificate authorities in the PKI. So that's what we'll have as part of the part one. So then we look at the TLS or SSL protocol, how it is helping in having secure communication over internet. So finally we look at HTTPS, that means secure HTTP, how World Wide Web is using TLS as the underlying transport layer protocol for achieving secure communications. So that way we have three parts. So today hopefully we can able to look at high level what is PKI and what the role of certificate authorities in the general internet for secure communication. So we have seen in the previous class about how one can use public key cryptography for secure communication. If you recall our discussion where we are talking about Alice and Bob. So in the context of web security, so we can assume Bob is like a web server. Alice is more like your browser which wants to communicate with a web server. So that could be the typical scenario. So we discussed about using a pair of public and private keys. In this particular C illustration, what you are saying is Alice is having, just hold on. Here Alice is having a plain text which is encrypted using the Bob's public key. Then we have the ciphertext which is sent over unsecure channel so that even anybody can eavesdrop. Whereas once the message comes to the Bob, uses the decryption algorithm, which is again in this case one can use RSA or any other such cryptographic algorithms for decrypting the message to get back the plain text. Okay. Here the assumption that we have made so far is somehow Alice knows the public key of the Bob, so that Alice can use the public key for encryption so that Bob can decrypt the message. So this is the setting that we have assumed in the previous discussion on public key cryptography. But what I want to ask you guys here is, in these underlying systems, do you think of any attacks that are possible? When Alice wants to talk with only Bob, can you think of any scenarios where Alice end up having unsecure communication with Bob or unable to talk even with Bob? So can you think of any scenarios when you are using communication in this particular manner?
Like anybody can claim to be Alice and send message here.
So anybody can claim to be Bob and send the message, or are you saying the opposite?
Like the opposite, because public key of Bob, everyone has like Alice.
Yes, everybody is supposed to be having the public key of the Bob. So what is the issue here? Are you talking about, see, if you look at and recall our discussion on what are the main requirements in terms of the secure communication, we looked at confidentiality, integrity, and availability. So if we look at those three properties, whether we are able to guarantee these basic requirement for secure communication in this particular context where Alice wanted to talk with Bob using the Bob's public key.
The confidentiality is not guaranteed.
Confidentiality is not guaranteed. How is it possible?
Known plain text attack, like he can get the cipher of whatever the plain text he knows, right?
And again, you are talking about Bob or Alice or whom you are talking
No,
about?
the third man, the attacker can get the cipher of any plain text he wants.
Yes, what you are saying is that because everybody knows the Bob's public key, and
He can generate the cipher of any like plain text he wants, and he can use some analysis to decrypt Alice's messages.
yeah, so that is one thing that is possible. Yeah, you are right. Yeah, anything else?
Availability can be compromised, sir, when a lot of like denial of services
Yeah.
can be enabled.
You are right, Prashant, and we were discussing in the previous class as well. Cryptography is not the solution for addressing availability, unfortunately. So that way, whether it is secure or unsecure communication, availability is something we have to deal with this separately. So any other issues that you can think of?
Sure. How does Alice know that PK Bob is actually the public key of Bob?
Yeah. So I think Anurag, I think in the previous class also, this is where I think you were asking about how does Alice comes to know that so and so is the public key of the Bob, right? So that is one of the major issue, and one attack that could be possible is somebody like Trudy can claim that so and so is the public key of the Bob and gives it to Alice. So without knowing whether it is indeed the public key of the Bob, Alice can start encrypting the communication using the Trudy's public key, so that Trudy can able to decrypt and understand what Alice is trying to send. One thing is, yes, Trudy can launch denial of service attack by dropping the messages that are coming from Alice to Bob, or she can simply decrypt the message using her private key and re-encrypt the message using the Bob's public key, so that Bob can also read the message. So here the issue that we are going to face is the confidentiality. That means it is nothing but man in the middle attack. Alice and Bob want to talk with each other. Somehow Trudy has come into the picture and told to Alice that this is the public key of the Bob, so that yes, we have a secure communication, but unfortunately secure communication with the bad girl here. So Alice is unknowingly talking with Trudy, and Trudy is again re-encrypting the message using the Bob's public key. Bob doesn't know that somebody has indeed eavesdropping on the communication between him and Alice. So here what is problem is the confidentiality of the communication. So is that make sense what I'm saying to all of you?
Sir, but this happens only if Trudy is there from the beginning. Right?
Yeah, this is possible only when Trudy is there. Yeah, for a given session, yeah, we have to assume that she is eavesdropping from the beginning. Yes, you're right. So any other attacks? So yeah, what about the data integrity? Do you think of any attacks that are possible on the data integrity or the communication between Alice and Bob?
Yes, sir. Trudy can send whatever she wants, right? Like since she has the public key of Bob.
And claim to be it is coming from Alice, right?
Yes, sir.
Yeah. So that way, as man in the middle or as woman in the middle in this case, Trudy can affect the confidentiality and integrity of the message. Of course, she can also affect the availability if she is dropping the messages coming from Alice to Bob. So that way, the man in the middle can launch all these three types of attacks. So today what we look at is how we can address the first two categories of the attacks on the confidentiality and integrity by using the public key infrastructure with the certificate authorities. Availability is again, it is entirely a different problem altogether. Let's look at how we can address the major two problems related with the secure communication. Okay, let's look at what is happening in this slide. So now we have brought in a new player or a trusted third party into the picture, which is called a certificate authority. I will talk about more on how these certificate authorities work. For timing, assume that we have third person or third party, where the certificate authority also has their own private key and public key pairs. And look at the illustration. Here we are using the terminology SK to represent the private key of the certificate authority here. And if you look at PKCA and PKCA, this is nothing but the public key of the certificate authorities. If you look at your web browsers or in the operating systems in general, whenever you install a new operating system or install any web browser, the root certificate authorities certificates are by default installed with your browser's root stores are called. Even in the operating system also, if you look at Windows and other operating system, we have these root stores which basically contains all these certificates. Especially the certificate talk about the what is the public key of these root certificate authorities. Okay, so here what we are assuming is somehow Alice and Bob have agreed upon or have trusting that so and so is the public key of the some well-known certificate authority. So we have here CA is the trusted third party. So this is one assumption that we are making. And the way how it works out is the Bob. In this case, I was mentioning it, Bob, we treat it more like a web server because we are talking about web security here. And Alice is the web browser. So what Bob is doing here is, Bob is generating a key pair using some public key crypto system like Bob can use RSA to generate key pair, public and private keys. And Bob is sending to the certificate authority that I am so and so is my public key. And Bob is asking the certificate authority to certify that I am so and this is my public key. So that Bob can install this particular certificate in its web server, so that when Alice is trying to contact Bob, which is the web server, Bob, as part of the HTTP communication, will send the certificate to the browser, which is Alice here. So if we come back and look at how Bob and certificate authority are talking with each other, Bob is sending its private key or his private key and what is the name to the certificate authority. So what certificate authority, like you might have heard about GoDaddy, and there are many other such certificate authorities that are out there who take your credentials. I mean, when I say credentials, what is your name and what is your street address, your mobile number and your Aadhaar card, your PAN card, whatnot. And also they take your private key because you only show your public key to the certificate authority. And then the certificate authority do the background check to identify whether it is indeed you are saying that you are the Bob. That means if somebody, as an example, somebody wants to get certificate issued for IIT Hyderabad website, and if somebody is go to, let's say, GoDaddy and start asking, please issue me a certificate stating that I am IIT Hyderabad and my public key is so and so, it is the responsibility of this certificate authority to do the background check and verify whether it is so and so or not. So it is a kind of a background or offline activity that is involved after you send a request to the certificate authority. So after validating that yes, you are so and so indeed, certificate authority, what they do is, he simply does only one thing. Certificate authority signs your information. That means your name and your public key are certified by the certificate authority by digitally signing. So that is simply the role of the certificate authority. CA is issuing a certificate where the certificate that is being issued to Bob is signed with the private key of the certificate authority. So once the certificate reaches server, that is the Bob, that means, as I was mentioning, this communication could happen physically. Maybe you will start visit the front office of GoDaddy website, the GoDaddy company, or you may be sending an email to them where you specify your public key and your credentials, and the reply could come maybe through pen drive, or it may come through email or whatnot. So after you receive the reply, you install the certificate in the browser, not in the browser, I mean in the web server here in this case. But before installing, you want to make sure whether this certificate is indeed genuine or not. So you want to make sure that whether this certificate is indeed signed by the trusted third party, not by some attacker or some intruder. So that can be easily achieved by using the public key of the certificate authority. Since you have known or you have got by some means that so and so is the public key of the certificate authority, you can validate whether the certificate is valid or not. If it is valid, then you install it and you start using it for communication with different clients who wants to connect with the web server. So that's how it is happening. Even when client is requesting the server to have a secure communication, the server is also gives the same certificate that was issued by the certificate authority to the browser. And even in the browser also we have the same public key of the certificate authority installed, so that we can easily verify whether the certificate is genuine or whether it is compromised or not. So by doing all this process, Alice comes to know that she is indeed talking with Bob, not with somebody else. So there is no chance for Trudy to come in the middle between the communication with Alice and Bob. If you recall our discussion on digital certificates, which are more powerful compared to using the checksums, and I was talking about this MAC authentication, message authentication codes. The digital signatures provide you data integrity, authenticity, and non-repudiation. So because of these three properties that are there with the digital certificate, we are using here the same digital certificate to make sure that Alice is indeed having trust that she is talking with Bob by looking at the certificate that is issued by a trusted third party out there here. So any high level queries here? Of course, I will going to discuss in more detail on how the entire thing is playing out in the next over the next 2 weeks as well. But at a high level, if you have any queries on how they are talking with each other, so yeah, please ask.
Sir, so Bob shares his public key with Alice along with the certificate issued by the authority, sir.
Tell me, Prashant, again.
Bob initiates a message to Alice with sending his public key as well as the certificate issued by the authority.
See, the certificate includes the public key of the Bob. You got the point? See here, the certificate is nothing but, see, certificate is here basically means only one thing. So and so is the Bob and with so and so as the public key. I am certifying by digitally signing that with my private key. That's what the certificate authority is doing it. So whatever the certificate authority has issued,
Hello.
same thing has been given here to the Alice.
Yes, sir. Got it.
Somebody is asking, yeah, who is it? Prashant, is it?
Rahul here.
Rahul, yeah.
As there are multiple certificate authorities, so means how it will ensure that this certificate is issued by a genuine certificate authority at the point of Alice. When he received that certificate, how it is determined this certificate is issued by a genuine authority?
Again, yeah, that's a very good question, Rahul. So as I was mentioning in the beginning, Alice and Bob in this particular example, who wanted to have a secure communication, they have to trust somebody as a trusted third party. So if you look at the internet, we have around 200 plus certificate authorities who is responsible for issuing these digital certificates by signing the public key with the name of the user who wanted to identify here. So the question is whether Alice wants to really trust or not. It is up to the Alice, but the assumption that we make here is you have to trust somebody or other. So, but by not giving this responsibility of giving this digital certificate to everybody on the internet, by using very stringent guidelines on qualifying or designating somebody as the trusted third parties, we can kind of ensure that Alice and Bob are having certificates that are issued by genuine certificate authorities. I will talk at the end of today's class. There were instances where Chrome and Mozilla started distrusting some of the certificate authorities, like Symantec, all of you know very well, one of the certificate authorities out there. So there was an instance where Symantec was found to not doing the due diligence when it is even giving the digital certificate. That means if somebody start applying to you, giving me a certificate stating that so and so is my name and so is my public key, it is the job of the trusted third party to do all the background check. In other words, it is very simple, like you go to your municipal office and you wanted to apply for a driving license, stating that I am so and so. So it is it is up to the responsibility of the municipal agency to make sure that they are giving the digital, birth certificate or the driving certificate, whatever it is, to the right person. So many times we submit all these, the passport, PAN card, Aadhaar, to prove that yes, it is indeed you are asking for the certificate, so that you are not, this is not issued to somebody who wanted to impersonate as you. Same process has to be followed here. But again, there are time to time some instances where these trusted third parties are having lost their trust and other certificate authorities started distrusting it. And there are also cases where in this case Symantec was actually acquired by DigiCert and they cleaned up all the mess. And in fact, our IIT Hyderabad website digital certificate was also kind of made distrusted, and we were asked to renew and get the new certificate from DigiCert. We have done it on time, so that when somebody is trying to connect to IIT Hyderabad website on the web browser, they can see that the padlock, that sign that you can see, it will be like a green color, or it won't be having X mark on that. Basically, it says that you are having a secure communication and you are talking with the IIT Hyderabad website indeed. So there are lots of issues, and I will talk about over the next 2 weeks many issues that are related to issuing the certificate and revocation of the certificates and other things.
Sir,
Okay. Hello, sir.
Yeah, please go ahead.
So, as we see, there are multiple malicious sites, and if we browse them, we found that there is certificate associated with it. So, how means they get what all the ground checks are done from the certificate authority to provide this certificate? Because
I think it is a very important question, whatever that you are asked, Rahul. See, when you are browsing a website over HTTPS, basically it means only one thing. Your communication with that website is secure, and somebody has issued a digital certificate for that particular website. See, a digital certificate says only one thing. Your domain name is so and so, your public key is so and so. But what you want to do with that website is up to you, right? So anybody on internet, as you were mentioning about who wanted to spread malware or Trojan horses or whatnot, so they can approach any certificate authority and register their domain name with their public key. When you try to connect to any of these websites, your connection to this website is secure. But what these websites are trying to send it to you, it is entirely up to you whether to trust and install their software or start browsing that. So that is not something that is addressed here by certificate authorities. See, certificate authority is basically giving you only one thing. Your name is so and so is public key. Only that particular thing is being ensured by digital certificates.
yes, sir. Yeah, got it.
So I will talk about this part in more detail as part of the part 3 of the web security, where we look at how TLS, that is the Transport Layer Security Protocol, is used in HTTP to provide web security. And as you are talking about, there are many issues related to authentication and whatnot. So we'll talk about those in detail. But today's class is mostly about how to get a digital certificate. and what you can do with this particular digital certificate that you get. So if you look at our discussion today, in this case, Bob got a digital certificate issued by the certificate authority, and Bob has circulated that certificate to Alice. So now Alice and Bob can have a secure communication, because as I was mentioning, the public key of the Bob is now known to Alice, so that she can either encrypt our communication using the public key of the Bob, so that only Bob can decrypt it. But as I was mentioning, when you are using the RSA for encryption for large size messages, it is quite time consuming. To address that problem, what we do in general is we don't use public key cryptography for encrypting the data. Instead, we use the public key cryptography to encrypt the secret keys. That means after getting the public key of the Bob, what Alice does is Alice generates a secret key and encrypt the secret key with the Bob's public key, so that Bob can decrypt it and also have the same secret key with him. After that, Alice and Bob can start having a secure communication using AES or any other such symmetric key cryptography algorithms. That way, encryption and decryption are much faster. So this is one purpose where Alice and Bob can use the digital certificate for a secure communication between themselves. And another purpose where one can also use the digital certificate is for digital signatures. I was talking about in the previous class. Each of us can approach any of these certificate authorities and get a certificate issued on our name. Again, the certificate says only one thing: your name is so and so is your public key. And the certificate authority also populate or propagates your public key throughout the internet. That means there is a periodicity over which all the certificate authorities certificates get updated in the browsers and operating systems, so that later point of the time when somebody wants to have communication, this certificate is readily available and can be validated before you start trusting and having a secure communication with them. So there are two purposes in general. One main purpose is for encrypting the data that you want to exchange between Alice and Bob. And other cases, when Alice wants to send something to Bob, even though she doesn't want to make it a secure communication, she want to say that, yeah, this message is not that secret, but she want to make sure that this message should not be tampered or denied at a later point by Bob. So I was talking about the non-repudiation and data integrity and those things here, authenticity. In that case, what we can do is Alice and Bob can use this also for digital signature. In this case, if Alice wants to send something to Bob, then Alice has to use her private key. But in this context, what can be discussed is, so far only Bob is having the public key, Alice is not having anything. So that way Bob can send a document to Alice by digitally signing that with his private key, and Alice having the Bob's public key, so that she can verify whether indeed the message is signed by Bob or not. So that process is very similar to the way certificate authority is signing the certificate for Bob using the certificate authority's secret key, so that Bob and Alice can verify at a later point in time. So that way, I'm talking about two objectives or two functions of digital certificate. One is for encryption of the data, other one is as the digital signature. Okay?
Sir,
Yeah.
sir, here first Alice has to send a request to Bob, no, sir, for getting the public key.
Yes, you are right. I'm not talking about that part today, Prashant. So I will talk about that as part of the HTTPS. When we're talking about the secure HTTP, you know, right? HTTP command that you use, like HTTP GET and other command. And after you are having HTTP handshake, then you do something called TLS handshake. In the TLS handshake, Alice sends something called client hello message. As a reply to the client hello message, Bob will be sending something called server hello message along with the certificate of Bob. So I will talk about this again as part of the part 2 of this web security topic. Okay?
Okay. And
So
one
again,
more thing, sir.
please.
Sir, for this browser and server, what which we are talking about is working on HTTP, which has TCP as the transport layer protocol, wherein we have the famous three-way handshake, and we may think like this kind of conversation of sending the public key and the private keys or something like that could be done during that handshake. But when we really want to use UDP protocol, then when will this digital signature exchange or something like that would be happening, sir?
Again, Prashant, again, I will come back and discuss this in more detail.
Okay.
See, we are talking about a TLS layer, which is transport layer security, which is there in the transport layer along with the TCP and UDP. So whether you want to have secure TCP communication or whether you want to have secure UDP communication, you do this TLS handshake, where these handshake messages are sent before you start doing your actual application layer messages. So we'll talk about those parts later. Yeah.
And this, sir, from server to browser, Bob will send key the public key of Bob to Alice. This is digital signature done by the Bob, no, sir?
No. The digital signature is issued by the certificate authority.
Yes, sir.
CA is the one which is signing the certificate. The signed certificate is stored with Bob. Whoever is trying to communicate with Bob, Alice is, in this case Alice, then the Bob gives a signed certificate stating that, okay, this is my certificate. You can also validate it because it is signed by a trusted third party.
Okay. It is signing with its private key or something like that, sir?
No, see, whenever we use the word signing, it is always with the private key of somebody. The word signing means private key. The word encryption means public key. Whenever we say you are encrypting, either with the secret key or the public key, depending on whether you're talking about symmetric key cryptography or asymmetric key cryptography. Whenever using the word signing, it only means that we are using the private key.
Okay, that means this certificate issued by this certificate authority is sent to Alice using Bob's private key.
No way. So look at here.
Then how is it a digital one, sir?
What is it? How is it?
How is it communicating with this Alice, sir, saying that this is my private key, this is my
Keep
public
Alice
key?
aside. Let's look at what is happening between Bob and certificate authority. Bob is requesting the certificate authority, please issue me a certificate by signing with your private key.
Okay.
So what Bob does is, what CA does is simple thing. He takes the message that is received from Bob. Okay.
Okay.
So the certificate authority receives the message from Bob, digitally signs that with his private key and send it back to Bob.
Yes, sir. Up to here, it's clear.
And now the certificate is now available with Bob, which is digitally signed by the certificate authority. Do you agree?
Yes, sir. Yes, sir.
So whenever anybody wants to talk with Bob, the Bob shares his digital certificate with that person or with her.
Okay. Using the public key of the certificate authority, it would be decrypting it, right?
See, certificate is not meant for decrypting. Certificate, you only have to verify it.
Yes, sir. Yes, sir. That means this certificate is would be with a secret key, no, sir?
Secret key of the certificate authority. Yes, you are right.
Certificate authority.
Yes.
So Alice would be decrypting that using the public key of certificate authority.
Yes. Yeah, she does the decryption on that part using the public key of the certificate authority, and if that is matching with the content of the message of the certificate, it means that yes, it is the certificate indeed issued by the certificate authority. Yes.
Okay.
Right.
Sir, what extra encryption does this give compared to digital signature? You were saying this has additional objective encryption of data.
No. So see, no, Harsha, I'm not talking about something extra encryption here. So if you look at, okay, you're talking about the public cryptography here, you're talking about this one?
I know, like you said, certificates give two objectives, used for two objectives, encryption
Yeah,
and
yeah, yeah.
digital
Okay, okay, that point. Okay, okay. So what I meant to say that, okay, let's assume that now Bob is having a certificate. What Bob can do with the certificate? So tell me what Bob can use the certificate for?
to prove his identity.
Yes, he can use it to prove his identity. So in this case, when Alice wants to talk with Bob, Bob is sharing his digital certificate with Alice, which Alice can verify, so that Alice has verified the authenticity of Bob, right?
Yes.
That is one thing. And Alice can use the public key of the Bob to securely communicate something to Bob. Is that right?
Yes, sir.
Similarly, Bob can send any message to anybody on internet by signing that message with his private key,
Yeah. So
which can
basically,
be
management
verified by
is
anybody on
divided.
internet.
Yes.
So that way, once I have a certificate, I can do multiple things with the certificate. I can use it for secure communication with other people, or I can use the certificate to digitally sign some document which are not meant for confidentiality, but where I wanted to ensure the authenticity of the messages and integrity of the messages.
Yes, sir.
Okay, so I will come and discuss about, okay, I think we have a lot of discussion on this slide itself, okay. And also many times these certificates I have certain lifetime, like typically 1 year, after that you have to renew it. So if you look at the digital certificates, so it is a data structure which is signed with the public key of the certificate authority, which does only one thing. It is binding a certain public key with some entity on internet. We are using the word Alice and Bob, but again, they could be devices, or that could be operating systems, or they could be people or whatnot. It could be anything on internet. Okay. So we use something called X.509 format for specifying the digital certificate. It uses something called ASN.1 notification, which is independent of the encoding technique, so that it becomes easy to exchange between different machines. Each certificate contains a signature. So this is what I meant by a certificate is signed by the certificate authority. But this is okay. There is something called to be signed. A certificate contains a data structure called to be signed. That is the one that is signed by the certificate authority. I will show you how that is being done here. So what you see here on the left hand side is the data structure of a typical signed X.509 certificate. As you see, the certificate has three components here. The first one is what is the thing that you wanted to sign? It is like some message, like if you have a document that you want to sign, you can treat it like this is the document that you wanted to sign. What algorithm that you are planning to use for signing this particular certificate. Okay. After signing the certificate, you will get a digital signature. So that is also kept here. So that way certificate has three components. One is the message or the kind of data element that you wanted to certify. What algorithm that you are planning to use for the signing. And after signing, what is the output that you get. So if you look at the first point here, that means the content of the digital certificate. It has lots of interesting fields. Like one of them is the version of the digital certificate. Currently, the one that we use is the version 3. And each digital certificate is having a unique serial number assigned by the certificate authority. And as I was mentioning, each certificate is signed using a certain algorithm. So then what is the algorithm? Each algorithm is given certain identifier. So you can look at what is the identifier of the algorithm that is used for signing. And who has issued the certificate? The name of the certifying agency is also mentioned here. The validity of the certificate from so-and-so date to so-and-so date, that is also mentioned here. And finally, to whom you are issuing the certificate? Is it the certificate that you are issuing to IIT Hyderabad, or you are issuing to some person who wanted to digitally sign the documents. So those details are captured as part of the subject field. And also there are many other identifiers that you can see, lots of extensions that are also there. So what happens is the certificate authority, whenever receives the name, like in the example that I was telling in the previous slide, Bob is giving his name. Bob also specifies his public key. Okay, this is the public key that Bob is giving. Bob is giving his name and his public key. Again, I'm using the word name in very generic context, but of late, whenever I use the word name, basically I'm talking about the domain name of the server in general, when you're talking about the web communication. Like in the context of any website, for example, IIT Hyderabad, www.iith.ac.in would be the subject name. And the computer center staff, whenever they are making a request for a digital certificate for IIT Hyderabad website, so they also generate a public key and send the public key along with iith.ac.in as a domain name to the certificate authority. Then what certificate authority do is they add all these additional fields, and using the algorithm that is defined here, they sign the they sign this set of messages that you see it here and add it as a signature. If you recall our discussion in the previous class on digital signatures, I was mentioning that very often you don't sign the entire message. I was mentioning that you will be signing only a digest of the message. So can you guys recall what kind of digest algorithm that are out there we discussed in the previous class?
Sure.
Yeah. So I was talking about MD5, which was originally meant to be a cryptographic hash function, but there are lots of vulnerabilities that have been found, like the collision-related resistance is no longer there for MD5 and SHA-1. So currently the one that you use is the SHA-2, and SHA-2 is the most popular one, even though SHA-3 is also available. It is not yet deployed. Yes, you take this certificate to be signed, you take the entire content that you see it here and you feed it as input to the secure hash algorithms like SHA-2. Like if you use the SHA-256, the output that you will get is a 256-bit message digest of the entire certificate that you see it here. Then using this algorithm that I am talking about here, the certificate signing algorithm, you encrypt the message digest. That means you take the certificate, you generate 256 digest, you are using SHA-256. That particular digest you encrypt using the private key of the certificate authority. So when you do that, whatever the signature that you get after signing with the private key of the certificate authority, that is also kept it here. So an example of, you can see here. Ranjita, are you asking something?
Sir, the algorithm is the encryption algorithm, right?
Say
Not
again.
the in the certificate in the previous slide, sir. There is one algorithm will be sent from the requester to the certificate authority, right? So, the object identifier algorithm.
No. Again, Ranjita, I was mentioning only one thing. If you recall our discussion here, Bob is sending only two things: his name and his public key. Only these two are sent by Bob.
Okay.
The certificate authority adds all these fields, the remaining fields, like in the example of Bob. Bob is sending only these two fields.
Okay, so the authority decides with which algorithm
Exactly.
he or she have encrypted, so that the other person can use the same algorithm.
So after that, this is the final certificate that is issued to Bob. And after receiving the certificate, by looking at the name of the algorithm, Bob can figure it out how he can validate whether the certificate is genuine or not. And again, basically what Bob does is after receiving this thing, because see this part is sent in, see all these are sent in plain text. Because certificates are meant to be public. There is nothing confidential out there. So Bob, after receiving the certificate, using the algorithm that is mentioned here, again he generates the digest, and using the public key of the certificate authority, he decrypt the message and verify that is matching with the signature field that is there in the certificate. If both are matching means yes, certificate is not compromised and certificate is indeed issued by the certificate authority claiming so.
Sir, here we might need two algorithms, right? One is for the digest generation and one for encryption.
Yeah, you are right.
So in
That's what I am showing here. If you look at this example here. So again, this is a bit old example, but again, whenever I am using the word signature algorithm, so look at here, it is saying that signature algorithm is SHA-1 with RSA encryption.
Okay, sir. Okay, thank you.
And nowadays, we are no longer using SHA-1 with RSA. Currently, many times if you look at what you see is the SHA-2 with RSA. Okay. And like a typical certificate looks like this. If you look at this illustration on the right hand side, we are looking at a digital certificate of the web server, of the mail server like mail.google.com, which is digitally signed by intermediate certificate authority, which is happens to be again a Google Internet Authority, which is digitally signed by GeoTrust Global Certificate Authority, which is again digitally signed by Equifax Secure Certificate Authority. If you look at here, there are actually root certificate authority that is at the top in the chain. Then you have two intermediate certificate authorities, and finally we have the end user certificate, which is issued to one of the user who wanted to have a digital certificate. I'll come and talk about why we have this particular chain of trust here. But for timing, let's focus on what is the content of a certificate that you can see it here. So here what is showing is, this is a certificate that is issued to the Gmail, which is expiring at so and so time. Here this particular green tick mark is kind of showing that currently the certificate is valid at the time. And this is the subject name. When I was talking about Bob is sending his name to the certificate authority for getting a certificate issued, Bob is providing all this detail to the certificate authority. Country name, state, locality, organization, and what is the common name. Common name is nothing but your domain name. Then the issuer has also similar fields out there. So if you look at on the left hand side, the additional fields like serial number of the certificate and the version number of the digital certificate, what algorithm that you are using it for generating the digest, and after that how do you are encrypting the digest, you have to mention that. So certificate contains these numerical identifier, but for our visual understanding, many times what web browsers do is they generate the human readable text for the corresponding identifier, and it is talking about the validity of the certificate. And if you look at here, it is showing that public key algorithm that you can use it here. It is in this case elliptic curve public key algorithm, where the key size that you can use is of size only 256 bits here, unlike RSA where you use either 1024 or 2048 bits. So let me show you IIT Hyderabad's our computer science department's digital certificate. I hope you are able to see my screen here.
Yes.
So again, at the high level, this is the summary of the certificate that you have got, and it is issued to CSE department, issued by R3. Basically, it is like Lattice Encrypt, which is one of the non-profit certificate authority that is out there. It has become quite popular in the last few years. And interestingly, what it does is it gives only the certificate for 3 months at max. As you see, our certificate is expiring March 19th this year. And they also come up with a mechanism to automatically renew the certificates. It's not that you have to make a phone call or you have to send an email and do all that. So there is a procedure using which your web browser, not browser, your web server can automatically contact the certificate authority for the renewal of the certificate. So there's a lot of interesting procedures that I will talk about hopefully in the next class. But yeah, this is how we got our certificate. And if you look at the certificate path, as I was mentioning, we have the certificate that is issued by R3, which is an intermediate certificate authority, whose certificate is issued by DST root CA. As the name says, DST root CA is the root certificate authority, which is basically issuing the certificate to the intermediate certificate authorities. Then they are allowed to issue the certificate to the end users. If you look at the certificate of our IIT Hyderabad, you can see the version number, serial number, and like look at the signature algorithm. It is SHA-256 with RSA and issued by Letters Encrypt and has the validity of 3 months. The subject is very important. This is the domain name. And the public key length. Now we can see the entire public key here in the hexadecimal format. And the enhancement key usage, we can use it for client authentication and server authentication. And also you can see there are 2 domain names this particular certificate is valid for, both www.csc and otherwise csc.ith. So this is what I was mentioning Harsha earlier. When you look at any certificate, it also tells for what purpose the receiver of the certificate can use the certificate for. So basically this is saying that CSC department of IIT Hyderabad can use the certificate to digitally sign any document that our HOD is want to issue any digitally signed document. Then our department can use this certificate for digitally signing any documents. Plus, we are also using this particular certificate to have a secure communication between any web server which wants to communicate with csc.ith.atc.in web server. These are the 2 different purposes for which one can use the certificate. And the certificate also contains a thumbprint. So this thumbprint is basically generated using SHA-1 on the public key that is out there. So don't confuse the thumbprint with the signature, and the tool that I'm using it currently doesn't use or doesn't show the signature as such, because signature is not meant for us to look at it. Signature is basically meant for the browsers and the applications to check the whether validity of the certificate and otherwise. So that way this particular tool doesn't display the signature as such. Thumbprint is basically a SHA-1 digest that is generated on the public key that is out there. It is there for historical purposes, but otherwise one cannot use it for any security purposes here. So this is the certificate, and if you look at the certificate path, even R3 also has a certificate. Look at here. This is the certificate that is issued to R3. Who has issued? The DST root certificate authority has issued the certificate to R3. And if you look at the path, now we can see that the certificate of the R3. What is it?
So what is R3 here?
R3 is one of the intermediate certificate authority. So in other name, I think if you look at here, look at it. Can you see the text here? Are you able to see the?
Yes, sir, but it's
the common name is R3. The organization name is Letters Encrypt. The country of the issuer is in United States. But now what I'm showing here is I'm showing the certificate of R3, which was issued by DST root certificate. So look at here, unlike end user certificate which are having typical validity of 3 months, the validity of the intermediate certificate authority certificates are having the validity of 1 year here, as you see, mostly. And again, they are also using SHA-256 with RSA different version number, and it is saying who has issued, the validity and RSA key, whatnot. And look at here, this is most important part. The Letters Encrypt can use this certificate that is issued to them by the root certificate authority for multiple purposes. They can use it for digital signature, they can use it for issuing other certificates. That's how IT Hyderabad got a certificate issued by Letters Encrypt. That is the meaning of certificate signing is the intermediate certificate authority can issue end user certificates. Okay, and also they can use it for something called here CRL stands for certificate revocation list. For example, somebody was issued a certificate, let's assume that certificate is valid for 1 year, but in between something goes wrong and we have to revoke the certificate. There could be multiple reasons. One could be the case that one company was acquired by other company and they don't want to continue the domain name of the previous company. In that case, you want to make sure that that certificate is no longer valid. In the case of end user certificates, if some user in the organization is leaving and if the certificate is valid beyond his tenure at the previous organization, then we have to inform to the certificate authority that this person is no longer working at so and so organization, please revoke the certificate. So the certificate authorities, both the intermediate and root certificate authorities, also have the power to revoke the certificate that were issued earlier. That way your browsers and the operating systems, whenever they are validating the certificates, they check the revocation list, the expiry date of the certificate, and also the digital signature that is out there in the signature that is out there in the digital certificate to check whether the certificate is indeed valid or not. So here basically it is saying that Letters Encrypt can use the certificate issued to them for also signing the certificate revocation lists. And let's look at the root certificate authority certificate, how it is looking like. What can you say about this particular thing?
Self-certification.
Yeah, so it is a self-certificate, and being the root certificate authority, there is nobody else out there to certificate their certificate. So it is like a self-signing of certificate, and also look at the validity of the certificate. And being the root certificate authority, their certificates are typically valid for multiple years. In this case, you see that this certificate is valid more than 20 years. And that way, one has to be very careful in designating somebody as the root certificate authority, because their certificates are very powerful, and any compromise of the root certificate authority is going to cause a great damage in the internet. So this has happened multiple times in the past, but it was addressed in a quick manner by other certificate authorities that are out there. Fortunately, there is not the case that we have only a single root certificate authorities. There are a bunch of root certificate authorities. They double check with each other. They self-sign their certificates and whatnot. Yeah, again, and interestingly, look at here, their signature algorithm is, as you see, earlier times we were using only SHA-1. You can see that this certificate is 20 years old and it was signed when SHA-1 was not found to having any vulnerabilities. That way you can see the hash algorithm that they were using is SHA-1, not SHA-2. And the key usage is somewhat similar to what you can find for the intermediate certificate authorities.
Sir, can anyone be the root certificate authority, sir?
Yes, see, anybody can apply, but as I was mentioning, there are stringent norms one has to meet before you are awarded as the root certificate authority. For example, Microsoft, Google, Amazon, all these are designated as root certificate authorities.
Okay.
And again, basically, you have to follow the best practices and the security frameworks and the policies. Then you will be designated as the root certificate authority. But the process is very, very, very cumbersome. And typically, they don't create too many root certificate authorities. But what they do is they let multiple intermediate certificate authorities like GoDaddy and other thing, so that they will be the front end when you are trying to get any certificate issued for your website. So the job of the root certificate authorities is to issue the intermediate certificates to the intermediate certificate authorities, and the intermediate certificate authorities can issue the end user certificates for encryption and for digital signatures.
Okay, sir.
Sir, who takes care of all these? Is there some organization or like IETF or something?
No. As I was mentioning, it is not like a single root. See, it is somewhat similar to the root servers that are out there for in the DNS system in the internet. So if you look at in the internet, we have many different root DNS servers whose job is to point out to the respective domain name servers, right? So something similar happens here, but unlike a DNS system, which is highly hierarchical, here this is also hierarchical in nature, but it is a kind of offline system. In fact, I will share you a couple of articles. There is something called a key signing ceremony. In fact, it is a purely offline activity. They meet in a closed room and they do all the process of self-signing of the root certificate authority keys and other things. They do entirely different approach when designating somebody as the root certificate authority and getting the certificate issued for the intermediate certificate authority. There's not a single person. There's no. It is a highly decentralized. There's no single entity on it. Yeah.
Okay. Is there a consortium who takes care of it? Like for RFC's standards and all, we have IETF, right? So similarly, is there any consortium which takes care of this, assigning somebody as root or like that?
Yeah. Of course, there is some consortium which is basically found by all the people who are currently designated as the root certificate authorities.
Okay.
They will decide whether to see. It is not really required to have too many root certificate authorities. In general, what they do is if somebody wants to become a certificate authority, they give the role of the intermediate certificate authority. But again, if there's any problem that they find with the intermediate certificate authority, then they also revoke or distrust that particular certificate authority.
Okay, sir. Thank you.
Sir, in the previous slide, I had seen elliptic curve public key, sir. Which part of the signing process was that used?
No. I think Harsha, it is a good question. If you look at, there are multiple things here. So are you looking at my screen here?
Yes, sir.
Okay. Let's look at in this case. As you see, there are three things that you can see. One is SHA-1. So can you tell me what is the role of SHA-1 here? So what is the purpose of SHA-1 algorithm here?
The signing of the message digest. I mean, the hashing the message digest.
Yes. We use SHA-1 for getting a message digest, right? And what is the purpose of RSA encryption?
Private key of the the certificate authority.
Yes, certificate authority uses RSA algorithm to sign the certificate with his or her private key, right?
Yes, sir.
Is that part clear?
Yes, sir. Yeah.
Okay, your question is about what is the use of elliptic curve public key here?
Yes, sir. Correct.
Okay, so here what this particular thing is showing is, yes, you can use SHA-1 with RSA to verify whether the certificate is valid and genuine or not. That is well and good. That is done. But after that, you wanted to have a secure communication between Alice and Bob. In this case, what is being shown is Alice and Bob are using elliptic curve cryptography with 256 bits as the key for the communication between them.
So this is like the protocol for like all communications with Bob after this certificate is issued.
Right.
Yes, sir. Got it.
So that is the part one. The signature algorithm is to verify the digital signature authenticity and integrity. And the public key algorithm, the information that you see, it is meant for secretly sharing the credentials and secret key so that Alice and Bob can have a secure communication. So this is for a different purpose and this is for a different purpose.
Yes, sir. Got it.
Okay, so I think I was showing similar thing. Where is it? Let's look at. Okay. So here, if you look at IIT Hyderabad's our CSC department's certificate, here we are using the RSA for verifying the signature, and also we are using RSA for secure communication as well. Can you see that part?
Yes, sir. Yes, sir.
Yeah, this is one case. I'm just trying to identify, is there any, okay, wait, I think I have it something here. Yeah. Let's look at this particular thing. This is quite interesting. Let's look at this path here. So look at it, is very interesting. Google got a wildcard certificate issued by an intermediate certificate authority, which is nothing but Google Trusted Services Certificate Authority. Okay, which is also signed by another root certificate authority, which is called Global Sign. Okay, so that you can see one root, one intermediate, and one end user here. Let me first show you. Again, it is also using SHA-2 with RSA. Okay, so can you see the subject here? Here the subject is wildcard, that means star.google.com. That way Google can use this for all different services like mail.google.com, maps.google.com and whatnot. It can run multiple services with same digital certificate. That is one thing that I want to show. I think, yeah, so this is the one I was trying to show you. So look at here. So can you see it is something similar to what you are seeing in the slides. Here the public key is elliptic curve cryptography with 256 bits.
Yes,
Yeah.
sir. Correct. Yeah.
Let's look at the global sign. It was issued in 2006, valid till this year December. If you look at the details, again, as you see, earlier everybody was having SHA-1 only for generating the digest. And the public key that is using here is, look at here. The root certificate authority is using the RSA for as the public key encryption algorithm, but in this case, the Google, which got a certificate issued by the intermediate certificate authority, is using elliptic curve cryptography for their public key encryption. Yeah, this is also, yeah, this guy also, I think intermediate guy is also using RSA, but only the Gmail is using ECC, not RSA. Okay.
ECC is like a little bit like less computationally expensive than RSC, sir. Like in
See, RSA and even there's also one more, the Diffie-Hellman. So these two algorithms are found to have sub-exponential solutions when you're trying to do the brute force attack. Because of this, of late, it is discouraged to use RSA as a public key algorithm, and it is recommended to use that elliptic curve cryptography, for which, as of now, no researcher has found a sub-exponential brute force attack. And because of the same reason, the length of the key that you can have with ECC can be shorter in nature. As you see, we are using 256 bits. But if you look at RSA, because there are sub-exponential algorithms where one can launch brute force attacks, to address that issue, the way it has been done is you increase the length of the key, because when you're trying to launch the brute force attack, you want to do the exhaustive search in the search space, right? That's the reason why you can see historically the length of the key when you're using RSA is increasing all the way up to 2048 bits. But since such problems were not yet discovered for ECC, still we are using shorter length keys, because you want to make the job of brute force attacker very, very time consuming, so that they end up not trying it, because it is so time consuming. But having said that, RSA is still very prevalent, but you can see RSA and ECC being very widely used as the public key algorithms in the internet for secure communication. So I want to show here one document. Are you able to see my screen?
Yes.
Okay. So if you look at IIT Hyderabad website, so earlier I was showing the CSE department, and this is our IIT Hyderabad website, and we also are using a digital certificate. So you can easily verify whether the certificate that we are using in the CSE department and the certificate that institute website is using the same or not. So can you able to figure it out from here? You look at the subject name, that means the common name. The common name that you see here is only iith.ac.in. It is not like wildcard common name that we are using. Earlier we used to have star.iith.ac.in issued by DigiCert, that has expired very recently, and because Letters Encrypt is giving anyway free certificates, even though the length of the certificate is valid for only for 3 months, because there's an automated way of renewing the certificate. So we have decided to get one free certificate for each and every department website, and let's have another independent certificate for the institute website. But also recently, even the Letters Encrypt also started giving wildcard certificate. But anyway, certificate is still valid only for 3 months. Yeah, so you can see that it is a fixed length. We can use it for digital signature, we can use it for key encipherment, that means for encrypting the secret keys and other purposes. And of late, we also started digitally signing any purchases that we make in our campus. So if you look at, these are some tender documents in our campus. Very recently we released one tender for automating various processes in the institute. Look at the document. This is signed by our assistant registrar in the stores. So any document that is digitally signed will have this kind of a stamp. But again, I don't want to say here that this is the digital signature. I think many people confuse the digital signature means it is like a physical signature that get embedded onto the document. Yes, it is embedded, but it is not visual when you actually open the document. As you see, this particular tender document, there is no confidentiality here, but whoever receives this document, they can prove in the court that yes, IIT Hyderabad has indeed issued this particular tender. It was signed by one of their employee on so and so date. So they can prove in the court. That way, It guarantees the integrity, authenticity, and a non-repudiation that are required when you're talking about secure communication, but not the confidentiality. Because anyway, this is meant for a public consumption. Invited to come and participate in developing such an online ERP system for our campus. And one last thing that I want to show before we leave for today is how do you parse the X.505 digital certificates. So far, what I was showing is, where is it? So far, I was showing you here how we can get a high level information about the digital certificate that is out there. But if you really want to see all the fields, as I was mentioning, where is that? As I was mentioning here, if you want to look at all these fields, including the signature algorithm and the actual signature. So far, I was showing that we cannot see the signature as such. But if you want to do that, you can use the parsers. Like you can also use the OpenSSL, which is there with Linux distribution that you use it. We'll talk about that part later and we'll do some hands-on. But for today's class, you can see one can use this decoder. And here what I did is I have taken a new certificate. Okay, it has gone. Okay. So IITH new certificate, the one that you have just seen. So I'm choosing that. I'm trying to decode that. So look at here, very high level information. It is basing that it is a certificate that is issued to IIT Hyderabad public website. That means the main website, issued by Let Us Encrypt. So look at, can you see the three components in the digital signature? The first one is the to be signed certificate. Here it talks about the version, serial number, the signature algorithm. In this case, we are using the SHA-2 with RSA as the encryption. If there are any parameter that also being shown here, and who is issuing, their details will be kept here. Okay, so as you see, there is a separate notation that is followed for specifying the issuer name and the validity. Subject, you can see here the domain name of the IIT Hyderabad, IITH.ac.in. Also, let me tell you here, now everybody on internet can download the certificate. Okay, interesting. So look at here. So where I was talking about the certificate, your connection to this site is not secure. So this particular link, whoever is hosting this web server, they have not got any digital certificate. And because of that, the communication between my browser to this web server is unsecure. Okay.
Sir,
Yeah, go ahead, Ranjita.
sir, here in when I browse through the IIT Hyderabad website, so when I go to Department of CSC, then a new session will get established then. Because
Tell me again.
From my browser, when I browse IIT Hyderabad site, one HTTPS, one TLS session would have been established, wherein the certificate exchange would have happened.
Right.
When I browse to the CSC department, a new session will get established because the certificates are different, right?
Yeah, you are right. Yes, right.
Okay.
You are right. See, even if the certificates are the same, then also a new session has to be established. See, HTTP is a stateless protocol, and everything has to happen from scratch each time you open any website.
Even when we when we move across tabs.
No. See, once you have already opened, and see when you are when you have opened multiple tabs, basically it means you have multiple long-term sessions that are happening out there. Even though whether you're actively using them or not, of late what happening is we are actually letting the TCP sessions to have long lifetime, so that we are not actually closing the TCP pipes, even though whether you're having activity or not. So
Okay, sir.
that is different. And also there is also case of user authentication where when you are inactive for so and so time, the web server, the AAA server that is there with e-commerce and other sites, they may either invalidate the session or ask you to re-log in with credentials. That is the user authentication that happens at the application layer. But at the transport layer, where you use the TLS and all, there is no change. Already you have the digital certificate, you have verified it, and there is nothing else that you have to do there.
Okay, sir. Thank you.
So one point I was about to say here is where is that? I thought I can download the certificate. Yeah. Look at here. So can you see my screen here? Now what I am doing is I am just opening the IIT Hyderabad digital certificate. I can store it in one of these different formats. Like as I was mentioning earlier, DER is one of the standard encoding format. Let's say okay, it is exporting. Actually, I want to import the file. I want to import this certificate. Copy to file. Okay, let me check it later. But
Sir, in mine there is a field called URI, and if you open that, then I'm able to download the certificate, the CRT file.
no, which browser are you using?
I'm using Chrome only, sir.
Where is that?
Like when I'm clicking on the certificate, basically I'm getting a slightly different tab
Okay.
than what you.
See, I will show you with other browser. Yeah, so now can you see here? Now I can export to file. Yeah. So now Classroom Google certificate. Yeah, it is a certificate that is used. And the point I wanted to make here is the certificate contains the domain name. And your browsers double check whether in the address bar also you have the domain name. They check whether the domain name that you see in the address bar is the same as the domain name that is mentioned in the certificate. That is one additional level of security that is out there. That way you can prevent anybody misusing your certificate. That means now what I have done is I have taken the Google Classroom digital certificate. Nobody is stopping me installing the Google Classroom certificate in a website that I am trying to launch. But only thing that I can't achieve is, yes, I can use their certificate, but anyway the data will be encrypted using the the public key of the Google Classroom. Since anyway I don't have the private key, I cannot do anything with that. But that doesn't stop somebody thinking that I am indeed the Google Classroom, because when they look at the certificate that is installed in my computer, in my web server, when they download the certificate over TLS handshake, they can see that okay, this website seems to be like Google Classroom, and they start communicating with me even though I cannot able to do anything with that communication. To stop those kind of DNS related attacks, the domain name that you see in certificate is double checked with the domain name that you see in the address bar when you specify the domain name and try to resolve that with IP address using the DNS servers. So that is also being done here. So I will talk about this again when we talk about the HTTPS, because there are lots of such complications that arise. So I want to access one of the tabs. It is not letting me to go. Okay. Finally, yeah, I was showing that, okay, this is the domain name. Yeah, the signature algorithm, you can see it is RSA with SHA-2. Yeah, so finally, this is the signature. So this is a signature that Bob, or in our example, Alice and Bob case, Alice can use the same SHA-2 with RSA to get back the signature and verify whether that signature and this one is matching or not. Both are matching, means the certificate is valid and not tampered with. So you can see only with OpenSSL or even this kind of decoder that are available online. But in general, the browser don't display this part. So I'm also showing here in my Windows computer the root certificate that are already pre-installed. Whenever I install the operating system, and periodically when Microsoft update the operating system, the patches and other thing, they update all the certificates. Can you see here on the left hand side? Yeah, we can also have your own self-signed certificate as well. But now what you can see is these are all the root certificate authority certificates. Can you see all of them are having expiry date? If somebody is having date in 2049, for next 23 years, hotspot certificate is valid. So these are all get pre-installed, and if you look at here, these are also self-signed, issued to hotspot by hotspot, issued to Microsoft by Microsoft. These are all the root certificate authorities which are all self-signed, which are having a long lifetime. And we also use the word, these are all offline certificate authorities. These guys don't issue certificate online and they are not available. It is unlike a DNS system where the root DNS servers has to be there in the resolving the domain names to IP address. They only issue the certificate which to the intermediate certificate authorities, and they can be working in offline using online portals to issue the certificate online and whatnot. But the root certificate authorities, they only work in offline mode. They one time they issue the certificate and they store their private key in some store which is not acceptable to anybody. They do all that. And you can also install additional certificate as well. As of now, I don't have anything that you can see it. Even if you are using Trust Smart Card, the Smart Card also contain digital certificates out there. So you can see all of them.
Sir, and in this certificate itself, I can get Bob's public key, right? Instead of asking him for his public key.
Yeah, here if you look at, see, any certificate contains the public key, yes, right. For example, if you look at here, it is saying that this particular certificate is having a public key of site so and so. So you are talking about the process between Bob and certificate authority.
Yes, sir.
See, it is the responsibility of the Bob to generate the key pair, public and private key, and Bob sends his only public key to the certificate authority. See, you don't want the certificate authority to generate public and private keys to Bob and sign the public key and somehow send the private key to the Bob. So we are not trusting the certificate. For example, when you install WhatsApp, or for that matter, whether you install Gmail app or whatever it is, in all these applications, what they do is they generate a public and private key, and your private key is stored in your own smartphone or your laptop or your computer. Only your private key is sent over to other party for doing the secure communication and other purposes.
So basically, this is Bob's public key, right? Like whatever Bob is sending, and that can also be accessed by Alice because she has access to the certificate.
Yes, yeah, right. See, public key is anybody's it is for public consumption, isn't it? So because of that, Bob generates and asks somebody like a trusted third party to say that yes, it is indeed Bob's public key, because if there is no trusted third party, Alice may not believe that that is indeed the Bob's public key, because somebody like Trudy can also impersonate and Bob say that okay, this is indeed the Bob public key, and start launching the man in the middle attacks. That's the reason why we bring in the trusted third parties whose job is to simply certify, and we kind of trust that these trusted third parties are trustable.
Sir, on our browsers, only the certificate authorities certificate will be stored, right?
Now, as I'm showing
In our
in my screen, these are the things that you see it in your computer. As you see here, the root certificates, and you can see also the intermediate certificate. Can you see here?
The third-party web server certificate will not be stored in the browser, right? That has to be requested every time when we try to establish a connection.
Yes,
right?
you are right. And as you can see here, where is it? Like you can see here, right? Your browser is saying the certificate is valid. Here you can see the way it does is whenever it receives a certificate, it uses the chain of trust. In this case, it is checking it anyway in the browser's root store. We have the certificates of the GTS and also you have the root certificate of the Global Trust Services.
Yes.
So we can validate this certificate of issued to the google.com by looking at the public key of the GTS. Similarly, to validate whether the certificate of GTS is valid, then we'll take the help of the Global Trust Services, because also you have these two certificates are also installed in your root store in your computer, whether it is a browser or whether it is an operating system.
Okay.
And since we are talking about, I'm showing here in the Chrome, when you go to Chrome settings security, under that, can you see it here? So this is inside the Chrome. As I said, each browser also have the root store, which contains all the root and intermediate certificate. Now you can see it here. The trusted root certificate authorities keys.
Yes.
And you can see other thing. And not only that, and I will also show you one more thing. What is that? So look at here. What I'm showing here is our previous certificate. As I was mentioning, Symantec was compromised and this was distrusted by Google and other browsers, Chrome and other browsers. Our certificate was indeed valid till this year, but in between we were asked to change our certificate, but this is our old certificate. Anyway, as of now, it is saying that it is expired or it is not valid. last year when if you had checked this particular thing, it would have told it is not valid because it was revoked. But currently it is not valid because it was revoked and also it is expired last week. And you can also install the certificate. That means even you can also create a certificate, and that means you can also become your own local certificate authority in our own campus, and you can start issuing digital certificate to each and every user in our campus. But since we are not a trusted third-party certificate authority, the browsers and the operating system don't trust the certificate that are issued by, let's say, our computer center. But it doesn't stop the users of IIT Hyderabad using these certificates. So the one way that can be addressed is you can take the certificate that is issued by our computer center and you can install that here using this import wizard. Then the certificate will be added into this path that you are seeing it here. You can install at the browser level or you can install at the operating system level. So it is showing other certificates and a trusted publisher and whatnot.
Sir, whatever is stored locally is done by the browser or operating system, sir?
No, see, browsers will have and operating systems also will have. See, for example, you are using a desktop application which wants to have a secure communication with a third party. In that case, the desktop application uses the certificate that are stored with the operating system. But nowadays, most of the browsers are also behaving more like operating systems, where you can run most of the things inside the browser itself. That is the reason why the browsers also have root stores inside the browser itself.
Can there be any problems if this is compromised, sir, whatever we are storing locally?
Compromised? Yeah, of course, right? See, that's why you can see that many times Google and many security agencies say that please update your browser because of late some vulnerabilities have been discovered. Some of them could be related to the revocation of the certificate that are found to be compromised at a later stage. But nobody guarantees that the certificate that are already installed in your browser, all of them are genuine or not. That means, for example, you want to install Chrome rather than going to Google website. Instead, you went to some third-party website which claims that they have Google Chrome with some add-on features. But as part of that, they may also start installing some other certificate, or they may modify the certificates of the Google or other thing that you would typically trust. Then you end up thinking that when you are connecting to these websites, you think that because certificate is valid and you see the green padlock, you think that you are indeed talking with the so and so. But it could be the case that you may be talking with somebody that you are not aware of. That way, you have to make sure that you are not using pirated operating systems. You are not using browsers that are not reputed in the industry. Like you should be using the most popular browsers which are quite aware of the security risks that are out there.
Yeah. It's like regular updates and also not using third-party distributions are important.
Yes. And otherwise, you can see, right, if you go to the Play Store or other things, you can see that there are so many browsers that are out there. But again, it is always very risky to trust all of them.
Sir, how costly is this process, sir?
Which process you mean?
This certifying digital, certifying process of digital certificates.
No, it is not that complex. Actually, I think they charge a few thousands of rupees for issuing one digital certificate per year to you.
Okay.
And also, I was mentioning, right, maybe I will continue in the next class. We have Letters Encrypt, which gives you free certificate, which is valid for 3 months, but they also come up with the tools like scripts using which you can automatically upgrade or renew your certificate after 3 months. Because of that, if you look at all IIT Hyderabad different department websites and the institute website, all these certificates are issued by Letters Encrypt, which are valid only for 3 months. But what our computer center is doing is we were actually telling all the web administrators of their respective websites to install a small script whose job is to see whether the certificate is expiring in next couple of days and start automatically talking with certificate authority to renew the certificate. I will talk about in the next class how that process happens automatically.
Nowadays, like the domain name providers itself, they provide the certificate also, no, sir? Like they do both.
Yeah, you are right. Yes. You will get the domain name and also the certificate issued. Yes. But it is not that you need to have a certificate to get a domain name. You can get the domain name without certificate as well.
Yeah, it is just that it won't be secure then. That green thing won't be there.
Yeah, you won't be there. I think I was showing, right? For example, this guy, if you look at, what is it? So this particular website, that php sec.lib.sourceforge.net, some domain name registry like a GoDaddy or somebody has given this domain name to this entity. But this entity didn't bother about having a certificate issued to them. So any other queries? I think it is a law. It's already late. I don't know how many are still remaining here. But okay, still 38 students are there. Okay, so any other queries before I close down?
Sir, not related to lecture, but in WebEx sometimes the audio is getting cut for me.
Who is that? Arsha.
Harsha.
Are you using Linux?
Yes, sir.
Okay. In the browser.
I
Yes,
had a
sir.
similar issue with Firefox Mozilla browser. Now I'm joining from Chrome. I'm not facing that issue. When I was joining from Mozilla, I too had a similar issue.
So which browser are you using, Arsha?
Yeah, Mozilla, sir. I'll try next time with.
Okay. So, yeah, see, that is also an issue, right? Yeah, because the developers of these video conferencing tools, they have to test their thing across a different operating system, different platforms and whatnot. So in the rush to upgrade and do many things, sometimes, you end up some issues here and there.
Even Google Meet doesn't work properly from Mozilla. It works from Chrome only.
See, basically, it is one way. It could be one way or one trick from Google to ask the people to go towards Chrome more and more. See, so now itself we are saying, right? It is not working that well, but it is working better with the Chrome. After that, what people slowly started moving and started using Chrome and Chrome when you are especially accessing the Google related services.
Yes, sir. Yes.
Yeah, again, we don't know what is the underlying business logic or whether it is a genuine technical problem. We don't know.
Yeah. But now, whenever I find any difficulty in Mozilla, I test it in Chrome. Mostly, it will be working. So it's like that kind of when from Linux, from Chrome, more things are working smoothly, kind of.
Okay, guys, and if anybody have any queries, please stay back for next 2 minutes. Otherwise, you can have the break.
Thank you, sir.
Okay, thank you.
Thank you, sir.